Hi everybody. Can I have the...
Yes.
I'm very glad to be your speaker for this talk about AI and specifically about Retrieval Augmented Generation, which if you don't know yet what is it, you will discover very soon. I'm Valérian Lebert, and I'm like a lot of us here, I'm a no-code builder. I build automation, internal tool. I have some other activity we can discuss maybe later on if we have time. Today, I wanted to share this talk with you because in the past time I learned a lot of stuff about RAG, and I think it's really interesting to understand not only as a builder but also as a general user of AI product, because what you will understand today is how any product like custom ChatGPT or a Notion question and answer do work, and it's interesting to know what are the strengths of this product, but also what are the limits and why they can't be perfect for any use case. So here is an overview of my talk. I have a first part where we will see the basics of RAG. A second part where I will show you the tool I did use to build a custom RAG. And the last part, and we'll go, if you were very quick, to see some advanced technique you can use to customize more the RAG system and process. So basically, what is an RAG? It means Retrieval Augmented Generation, and it's a concept about improving your AI, your language model, with an external database and, above all, a retrieval process. That means how can you search in the knowledge database for relevant information based on your user question. And as I said, a lot of us build tools for companies, so it's nice to know how to build it, but we are also using RAG without really knowing it, and it's nice to understand what's under the hood. So firstly, why do we need such architecture? The main reason is the limitation of a language model, the context window. If you have a large knowledge database, for example, company knowledge or very domain-specific knowledge, well, two options. The first one, basically, it can't fit in the context window because it's too big. GPT-4 have about maximum 200 pages of text context window. You may have a lot more knowledge than this, and if you have maybe a small knowledge database, the more context you give the system, the more expensive is the query, the more slow is the query. So generally, in any case, you want to limit the amount of context you give your model to be the more specific as possible. And that's where we are going to use embedding. I don't know if you have already heard about embeddings. It's a very complex mathematical concept, just like LLMs, and it consists of converting plain text information, for example, in a numerical world. So in this example, for example, it's a two-dimension representation. And here, if you have a text about buses, a text about car, they will be close together, and a text about middle age has nothing to see. It will be far away in the numerical world. This is the big picture. Real embeddings are like 3,000 dimensions, so your brain can't figure it out. But in these 3,000 dimensions, related information is close together and unrelated information is far away. And that's where we are going to use to build our smart lookup process. And it's very complex, but you can use it with API, just like an OpenAI LLM, and you can use it with Mistral AI, or any AI provider provide also an API for embedding models. So how do we do step-by-step a similarity search? First, we build a knowledge database. That means we store somewhere all the text of our knowledge and its vector mathematical representation. Secondly, the user asks a question. You calculate the vector representation of that question, and you compare it to all the vector of your knowledge database. And thirdly, you keep the closest items of your knowledge database, you feed it to your language model, and then your language model have the question, have some related content, and is producing an answer based on the knowledge. And here comes the main problem of RAG. They are not 100% relevant. For example, if you have a knowledge database about car and you ask, okay, I'd like to find a cabriolet German car driven by James Bond. You have a lot of semantic in this question, and embedding should work efficiently. If you ask, which is the speediest car, any car have a speed, the embedding will respond all the car, and you will choose randomly maybe 10 items to fit to the LLM. You have no guarantee that the LLM will tell you which is the speediest car of the total database. So it's a limit which I did discover in my business case. You can't ask anything to an RAG. So let's get to the tools and some fun. What tool do you need to build an RAG? The first tool is a vector database. That means a space where you will store each item of your knowledge content, so text content, its associated vector representation, and some metadata. We can see later on why we could use metadata, for example, but basically it's 2 columns. One line, the text of your document, it's a numerical embedding representation. The famous vector database are Pinecone, I guess. I never use it, but I guess they are the major player. I see them anywhere. ChromaDB is an open source player. And also PostgreSQL, more old school, also open source with pgvector. This is the one I do use because you can use it with Supabase, which is a nice PostgreSQL provider and a good free tier to begin to play with, and you can do a lot of stuff with just a free Supabase plan. The other set of tools you need is automation tool and front end. And N8N, or you can say N8N is also called Nodemation. I don't know if you're aware. And Nodemation offers us the chat trigger, which is just like a webhook, plus an added chat interface you can embed in your website. And anytime a user will send a question in that chat interface, embedded anywhere, it will trigger the scenario, just like a webhook, and receive the response of the workflow. It can also handle chat history. So at the end, you will maybe end up build your own chat interface, but it's easy to begin with, easy to test some chat interface. This is actually a chat interface actually working, two blocks. And the other cool feature of Nodemation are long chain nodes. Long chain nodes are ready to use AI blocks, so language model, vector database, a retrieving process, and you can build complex AI workflow and easily switch from OpenAI to Mistral AI, from Supabase to Pinecone in just one click. So it's made to build complex AI process and made to be interchangeable with any provider. So let's see now how can you personalize your and what you should be aware of when you build an actual RAG. So I will be quick on this one, but you have to figure out how will your knowledge database live in the long term. How can you know what is the current state of document in your database? How will you add a document? How can you remove a document, update a document? There are solutions, a bit coding, a garage solution, or you can build your own process, but you have to find a way to maintain it in the long term. And with this will be done with metadata. For example, in the database, you will store the title of the document, its category, or you can also add some nice information. When you add a document to the database, ask an AI to read it and to categorize it, to extract keywords. So metadata will be used for the maintenance of the database, and also if you want to pre-filter your database before proceeding to retrieval, you could be more efficient. If you know you ask a question about car, just don't feed your retrieval process with a document about planes, for example. Second important rule, any informatic system follows the GIGO rule, garbage in, garbage out. So you need to feed your database with clean data. What is clean data? It means you will avoid data redundancy. If you have duplicated document, you will ask a question, and instead of having 10 maybe different sources of information, you will have 10 times the same document and provide a bad answer. You will have to work with PDF, and it's always a pain to extract clean text from PDF. You have images, you have tables with grouped cells, cells containing some picture or a stupid character, and you have to find a way to clean this mess. And one way which is working quite well is having a pre-process the data with AI. You can read the images with AI, convert them to natural language. You can convert the table to images, and convert the images to natural language. And above all, you can focus on the business case. If you know what you build your system for, you can digest the information and maybe not store the full information, but reorganize information to be more efficient for the big business case you want to solve with an RAG. So I had the best result when I did not feed the database with just plain text coming from my document, but by reworking the document with AI. Okay, maybe you spend $200 of GPT credit, but at the end, you have a good result. This one is fun. I like this graphic. Another parameter is a chunking strategy. Chunking means slicing. When you build a knowledge database, you will not store like one line, one document, but you will slice each document in a chunk of the same size, approximately, maybe 1,000 words or approximately, and you have two parameters. What is the size of the chunk, and how many chunks at the end you will provide your LLM to give an answer. If you increase both direction, you increase the overall context and you increase the cost of your system, and there is a limit you can't cross because either it's technical or financial, but you can't go infinitely in that direction. And then you have two strategies which depend on of your data and your business case. Do you want a system that will have a lot of small information and analyze, digest them, and provide an answer? Or do you want a system that will find just the perfect information with a lot of context and give the solution? And there is no good strategy. It depends on what is your information at the origin and what business case you want to solve. How many time? Oh, I'm very fast. Retrieval techniques can be added to improve the retrieval process. So the first technique is multi-query. You ask a question. Before doing the embedding stuff, you will have a first prompt that will divide into different routes with different alternate query. So you will have a prompt, give me 3 rewording of that question. You will perform 3 retrieval process, and then you will combine the best matching items of each route to the final route. Contextual compression is a technique where you use a more chippier language model to pre-filter the information you will give at the end to the more capable LLMs that will provide the final answer. Actually, I didn't really like this technique, but it still exists in the literature to have to find more information and have a first level of cheap LLM and then a final level of LLM to provide the answer. The last one actually is very important, hybrid search. It's the fact of combining the embedding search, as we discussed before, and a classic keyword-based search, because in some cases it's more efficient. And vector database provides this natively, or sometimes you have to build it. For example, you will have a prompt that will extract the keywords, and then you will do a keyword-based search on your data. But you have to mix those both worlds to have better results. So here I share with you all I wanted to teach, I hope. At the end, I think building AI tools for us, no-code builder, is a lot of fun because you have a lot of blocks to play with. But I find it very more time-consuming than I thought, because you have a multitude of parameters you can try without knowing exactly what will happen at the end. So it's die and retry. You move something and you have to regenerate 100 responses to see if they are better or not. It's a lot of time just to play with different parameters and not be sure of what will happen at the end. Like I said, it's unfortunately not 100% reliable. But when it works, you're very happy, and your user have a perfect answer based on very specific knowledge. It's very rewarding. And my advice after this experiment is not to do an RG system to do everything and any question, but try to focus on a specific business case, organize the database according to that business case, organize the prompt and the retrieval technique according to that business case, and then you will have some efficiency and maybe build different tool for different use case. Thank you, and I will be glad to answer a question if you have.
Thank you so much. Good job,